Now, in industrial process, we also look at another parameter called turnover number. And most of the enzyme, they have very high turnover number when they are active. Okay, so again, we consider these following reactions. So how fast, again, products can be formed? How fast product can be formed? It depends on the ES complex, the concentration. Correct or not? Okay, so turnover number actually is described as the number of substrate molecule, okay, that can be converted to product per enzyme molecule per unit time. Now, this is very important. If we look at the definitions, okay, don't worry about KCATs here yet, but the turnover number is defined as the number of substrate molecule that can be converted to product per enzyme molecule per unit time. So it means that I want to form the products. So if I want to form the products means that how fast I can break down the ES complex. Don't want to form ES complex. So it depends on which equation. Again, equations number 2, reactions number 2, and therefore the rate against the rate of reaction 2 V0 equal to K2 ES. And this K2 actually represent the turnover number. Are you clear? Okay, and we give them a new name called K catalyst, KCAT. KCAT actually indicate the turnover number. So for our syllabus, you just need to know the definitions of the turnover number, full stop. That's all. So what is the turnover number? Turnover number is the number of substrate molecule converted to product per enzyme molecule per unit times. Are you clear? So how many enzyme molecule? You divide by enzyme molecule, then you will be able to know how fast these reactions, okay, the turnover number already. So you can see that, okay, I use this symbol. So basically means that not in our syllabus, just for informations only. Okay, so you look at this, we know that when V0 equal to Vmax, okay, when this one, I think I should put when V0 equal to Vmax, we know that all enzyme substrate complex, actually the concentration of the enzyme substrate complex equal to the total enzyme concentrations. Correct or not? Right, because when Vmax happen, you have to understand what is Vmax. When Vmax means that the substrate actually concentration is much more higher than the enzyme, and substrate concentration no longer act as limiting factor, right? So means that whatever enzyme that add in now already become the enzyme substrate complex, because all enzyme active site now fully occupied by the substrate. So when they're fully occupied by the substrate, so means that if I give you hundreds units of the enzyme, I should get hundreds units of the enzyme substrate complex. Okay, and Vmax now, can you see that? Vmax equal to KCAT multiplied with the enzyme, total enzyme. So means that KCAT actually, according to this formula, we can calculate. Once we have the Vmax value, then we know what is the enzyme that we put it in. Okay, when this, can you see that? The total enzyme that we put it in, then I can calculate the KCAT value now. Are you clear? Once I have Vmax. Okay, so what is ET? T stand for total. So total enzyme. For example, initially I add in 100 unit of enzyme, and because when Vmax take place, then I will have all my total enzyme now will become total or substrate ES complex already. Are you clear? It's a concentration of the total enzyme, not free enzyme. Total enzyme. So in this case, free enzyme equal to 0 lah, right? No more free enzyme already. Free enzyme concentrations will equal to 0. So T stand for total. Okay, so in this case, because we know the Vmax already, right? From the previous equation, we know the Vmax already. We know what is the concentration of the enzyme we added in. So we can actually calculate the KCAT already. KCAT will equal to the Vmax divided by the total enzyme. So this is for your informations only. So you can see that some of the enzyme here, the KCAT, how fast? So KCAT actually is per second. KCAT actually is per second. So means that, what does this mean? Carbon anhydrase is the one of the highest turnover number enzymes. Why? Because every second, can see how fast, huh? Maybe you can't imagine. I also can't imagine how fast this process can take place. Every 1 second, every single carbonic anhydrase, this enzyme can convert 600,000 of the substrate into the product. Can you imagine how fast? Every second, every second, every single molecule of carbonic anhydrase can convert 600,000 of the substrate into the products. Are you clear? Can you see that? So acetylcholine esterase, we're going to learn this one again. Okay. So 25,000. Lactase dehydrogenase, we're going to learn this also in 1,000. You can see that 1,000. So different enzymes, they have their different turnover number. The higher the turnover number means that I will get the product faster. I mean, in a shorter period of time. DNA polymerase 1, tryptophan synthase, you can see that different enzymes, they have different kcats or turnover number. So if given the kcats now, I also can take, I can calculate the time taken to convert one substrate into the products by calculating, okay, by using this formula. Okay, so for example, every 1 second, I only have 2 substrate can be converted into the products. So what is the time taken for one product to be formed? So use 1 over kcat. So every half second, I will get 1 product to be formed. So again, this formula just for your information only. Okay. Now, how the question can ask you? So most of students say, what I learned about turnover number. So again, what you need to know, turnover number actually is the number of substrate molecule converted to product per enzyme molecule per unit times. So basically, the unit is per second. So in this table, the question can give you a table and give you the formula and ask you to calculate the time taken. So time taken, very simple. For example, let's say, so we use the tryptophan. Easier to calculate, okay? Synthase. So we know that the kcat, the turnover number equal to 2, okay, per second. So what is the time taken? So time taken is 1 over kcats, right now. So time taken is 1 over 2. So it means that every 0.5 second, I will get 1 product from 1 enzyme. So now, what is the use in this case? What is the use in this case? If in the industrial process, you know that your enzyme have very low turnover number, because each enzyme 1 second can convert 2 substrate into product only. So you know that I have to increase the substrate, increase the enzyme concentration. Correct or not? If my turnover number is low, I have to use more enzyme. If I didn't use more enzyme, definitely my products form will be low. Can I change the kcat? You can't change the kcat. Okay, you can't change the turnover number. So in order to gain more products form per unit times, means the rate, increase the rate, I need to increase the concentrations of the enzyme. Are you clear? So now, sometime in the industrial process, we have a choice. Let's say, okay, I have enzyme A. So this enzyme A converts my substrate into the product. But I have different enzyme A's. Enzyme A can get from the yeast, can get from animal, can get from plant. So which one better? Then I will have to check their kcat, the turnover. Let's say enzyme A from species 1, the kcat equal to 2,000. A2 equal to 3,000. From source number 3, 30. So source number 4, 2. So in the industrial process, you know the turnover number already. Definitely you're going to choose enzyme from source number 1. Why? Because every second I can convert 2,000 substrate to products by 1 single enzyme A1. Can you see that? So it's why we choose A1, A2, sorry, A2, because 3,000, sorry, is higher. So I will choose A2. Why A2? Because when you use A2, I can convert 3,000 substrate into products in 1 second by 1 enzyme molecule. So this is why we choose enzyme A2 rather than A1, A3, and A4, because their turnover number slightly lower. Okay, so with this, I have done for today lessons. You can try the checkpoint 4.8. I will go and open it later. Okay, so that you guys can try the questions and then you can check, okay, how much you actually understand about the enzyme kinetics. Okay, so with this, I've done for today lesson.